Leetcode problem. 516. Longest palindromic subsequence. So we need to understand what is a subsequence. So the subsequence is defined by deleting some characters of a string. For example, character A, we're gonna get BB and BB. So that's gonna be a palindromic subsequence, and we want to get the longest. So for this example, the longest is 4, and for the second example, the longest is only with BB, because we can delete C and D, and this is going to be a subsequence, and the longest is only 2. And the length of the string is 1000. So this means basically we can solve this problem by using DP. We can use the longest common subsequence DP, or we can solve it by using the optimized way, the interval DP. So let's just try to solve it by the longest common subsequence. So the idea is that, so for example, we have a string with BB, B, AB. If we reverse it, if it is a palindrome, the relative sequence cannot be changed. For example, if we reverse it, it's gonna be like BA and BBB. And after that, we're gonna check the longest common subsequence. So the longest subsequence is gonna be BB and BB, because here are 4 B's, and here with this B and those 3 B's. So it means, yeah, the longest common subsequence is 4, and we can return it. But for this way, basically, we're gonna prepare a DP, and we're gonna check all the tables. So this is the time complexity is m times n. Yeah. But the interval DP, the time complexity, gonna be m times n divided by 2, but I'm gonna talk about it later. Let's first try to solve it by using the longest common subsequence DP. So I'm gonna define a LCS, longest common subsequence, and inside normally I'm gonna prepare S1 and S2 as my function. So yeah, let me just finish the template, because for this problem, I'm gonna focus on the interval DP, yeah, because that is the optimal way. And for the C, it's gonna be the S2 plus 2. So let's first prepare this DP. So it's gonna be 1. Yeah, it's gonna be 0 times R times C for R in range capital R. And for, yeah, so this plus 1 is a padding for this column, row and column. So I prepared a padding for R in range capital R for 1 to capital R, and for C in range from 1 to capital C. So I'm going to compare with it. So if S1 R minus 1 equal to S2 C minus 1, so this means they are equal. So the longest F R C gonna be F R minus 1 and C minus 1. Yeah, because this one is equal, so I'm gonna plus 1. So if they are not equal, so FRC gonna be equal to the maximum of FR minus 1 with C and FR with C minus 1. Yeah. And finally, I'm gonna return F minus 1 and minus 1. Yeah, because this 0 is just a padding, and yeah, we just compare with it. Yeah, we just compare. For example, we have BB and BB, but we prepare an empty string, so this is just like a padding, and here is another B and B. So we're going to compare this one and this one. So if from the first position, if they are equal, so this means from here, this is going to be 0 and plus 1. So the longest common subsequence is 1. And then I'm going to compare here, and they are equal, and this one, 1 would plus this one. This one is 1 plus 1, it's going to be 2. So if they are not equal, if this is a C, I'm gonna compare with this b and this b before it, this b and bb before it, yeah, or this b and bc, yeah, but both of them are gonna be 1. So this is the idea. Yeah, now we can just return the LCS with s and s reverse. So we just need to reverse it. So this is the longest common subsequence idea to solve the problem. Now, as you can see, it works, but this is not the best way to solve the problem. So normally for such problem, it's even difficult for you to think about the longest common subsequence because the normal way is the interval dp. Although longest common subsequence is a dp, also is a dp pattern to solve the problem. But for this problem, basically we loop through all the rows and all the columns. As you can see, it takes time and space. Yeah, but another way it's gonna be much better. So another way it's gonna be the interval dp, because we're gonna only check half of the table. We will not check all of the table. Yeah. Now let me just submit it to check the time of this method. Now, as you can see, it is very slow. It takes more than like it takes more than 1 second, nearly 1.5 seconds, because we used all the table. Now we are going to use another way. That is a much better way to solve the problem and a much normal way to solve such problem, because we don't need to check all the table. We only need to check half of the table. So the problem is going to become an interval dp. So the interval dp is defined from the index I to j, and my definition is from index I to j, I'm going to check what is the longest common subsequence, and how I check it, I'm going to check it let it become smaller and smaller until I find a solution, and this one going to be the final solution. And then I just like the recursive function, I just let it go back and check from dpi to j and dpi minus 1 to j minus 1, or I just let it smaller and smaller until I get to the solution. But in this way, I just need to use half of the table, not all the table. Yeah. So first of all, let's try to write the easy way. It's going to be a test with DFS, because this is much easier. We can just write a recursive function to solve it. So dpi to j is defined from index I to j, what is the longest palindromic subsequence. So first of all, we're going to check the edge case. So if I equal to j, this means the boundary case, there must be only one character, so we're going to return a 1. But what if I more than j? It means it goes out of the boundary, there's no characters, so we're going to return a 0. Then we're going to check if si equal to sj. So this means we can check from both ends, the left and the right side. We don't need to check like before. If it is the longest common subsequence, normally we compare the character by character 1 by 1. But here, we directly check 2 characters at the hand and at the tail. This is why it is so fast. So if they are equal, and we're gonna check the subproblem. So the subproblem, we're gonna have a return. So the subproblem is gonna be smaller. So it's gonna be I plus 1. And j going to be minus 1 plus 2, because they are equal. Else, they are not equal, so I'm going to choose the maximum of the 2. It's going to be dfs I plus 1, and j going to be fixed. Another is dfs I going to be j and minus 1. Yeah. So this is going to be the final solution. And finally, we just need to return the dfs from 0 to length of the string and minus 1. Now let me submit it to check if it works. Now, as you can see, it is much faster. It is the half time of the longest common subsequence, because we just use half of the table. Of course, it's going to be half of the time. We use the half of the table, it means half of the memory and half of the time. Yeah. Now we're going to turn this problem into a real DP, because this is a DFS plus memorization. Yeah, normally it is okay, but sometimes it's going to have the memory issues or time issues. If we want to let it run much faster, we normally going to use the DP. So the DP idea is similar like the recursive function DFS. So for the DP, we're going to also check the edge cases. It is I equal to j, and I I more than j. So there are two edge cases. Another case is that we want to for the dpi, it is always coming from dpi plus 1. It means it is coming from a bigger value for the I. And for the j, it is always coming from a smaller value. It means j minus 1 to j. So this means for our definition of the dp, it's gonna be bottom up. Yeah. So because the I gonna become because the I is coming from I plus 1 to I. Yeah, if it is I plus 1 to I, it means it's gonna become smaller and smaller. So it means it's starting from this position, it is the bottom up. And this is I, and I minus 1, I minus 2, until I equal to 0. Yeah, here is n minus 1, maybe. Yeah, and for this j, it is become j minus 1. This is j minus 1 to j. And j becomes bigger and bigger. Yeah, so this means j gonna come in from this I plus 1 and become bigger and bigger. Yeah. Now we can use this kind of recursive function to turn it into a real DP. Yeah. So our intuition is that I gonna become smaller and j gonna become bigger. Yeah. Now let's try to write the real DP. Let me make a comment and write DP from here. So I'm gonna define a function f. It's gonna be I'm gonna prepare a variable n and gonna be length of the string, and function f gonna be 0 times n for r in range with n. So this is gonna be the DP table. And now we're gonna check from the I to j, and I gonna become from bigger to smaller, and j will become from the smaller to bigger. So I in range bottom up is gonna be n minus 1 to minus 1 and minus 1. And for the j, it's gonna become bigger. So for j, gonna be in range with I plus 1 to n. Yeah. But before we check the for loop in this j, before we check the range, we need to set the definition if they are equal. So fi should set to be 1, and except that all other areas are gonna be 0. So the table gonna be like this, and this area is gonna be 1, and this area is gonna be 0, and then we're gonna check the DP from bottom up until we get the solution, and the final solution gonna be at this point. It's gonna be f0 to n minus 1. Yeah. Now we can check. So if si equal to sj, this means at the both ends they are equal. So fi j would equal to fi plus 1 and j minus 1. It's going to become smaller and plus 2 because they are equal. Else, if they are not equal, so fi j would equal to the maximum of fi plus 1 to j and fi to j minus 1. As you can see, it's similar like this. I plus 1 to j, j minus 1 with I, j minus 1. Yeah. Finally, we just need to return this f from 0 to n minus 1. So this is the bottom up. And the longest subsequence idea, that is the top-down solution. Yeah. But this is the bottom up, and this is much better than the top-down. Now, let me just run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can pass for all testing cases. As you can see, it passed for all testing cases and it becomes 95%. It means this is the best solution to solve such problem, and it is much faster than before. And the time complexity is m times n, or n squared, and the space complexity is also n squared, but actually it is n squared divided by 2. Thank you for watching. See you next time.